We just looked at some of the fundamentals of how to evaluate association rules. So let's take a simple example to work through before we start using a tool like RStudio or Excel Miner. You can read the question to yourself for a few seconds. So this is about an electronic retailer who is interested in knowing that whether a person who buys an expensive TV is likely to buy a high-end PC, or if a person buys an expensive TV is also likely to buy a music system. So we have two rules for this particular question. So if you read the description of the problem, we can identify some of the numbers here. For instance, you know the number of transactions. I'm going to write it here. Number of transactions. We have 5,000. Okay. The number of customers who have bought TV is 650. The number of customers who bought TV and high-end PC is 400. The number of customers who bought TV and music system is 450. The number of customers who have bought high-end PCs is 800. 800. And the number of customers who bought just music is 2000. So we have the basic statistics here. Now we need to calculate what is the confidence level for rule A. If a person buys expensive TV, then he or she is likely to buy high-end PC. So this is nothing but your probability of C given A. C refers to high-end PC. A refers to your TV, expensive TV. So this is nothing but the number of transactions with A and C divided by number of transactions with A. So A refers to here the expensive TV and C refers to high-end PC. So it's A and C, which is TV and high-end PC, is 400 divided by the number of transactions only with A, which is 650, which is equal to 61.5%. That's the confidence. So the confidence of A is 61.5%. Likewise, if we do for confidence level of B, here it is TV and music system. So likewise, number of transactions that has TV and music is 450 divided by the number of transactions for high-end for expensive TV is 650, which is 69.23%. Now we need to show how useful are these rules. Does it have any meaning? So in order to do that, you need to first calculate the benchmark ratio. So we are interested in high-end PCs. What is the likelihood people will buy high-end PCs? We know that there are 800 people who bought high-end PC out of 5,000. That's your benchmark. The likelihood of somebody buying is about 16%. 800 divided by 5,000. So we know that anybody who walks in and buys something, the likelihood of somebody buying high-end PC is 16%. So now I want to know what happens to this probability if somebody has already bought an expensive TV. So PC, the lift ratio, this is nothing but your probability of C. So we know the lift ratio is nothing but probability of C given A divided by probability of C, which is the benchmark ratio. So confidence divided by the benchmark confidence. So the first one we know that is 61.5. So it's 0.615 divided by 0.16, which is equal to 3.84. So what does that mean? The likelihood of somebody buying a high-end PC goes up by 3.84 times if they have bought an expensive TV. So it's a very meaningful rule because we now know it's good to target people who have bought expensive TV because they are very likely to buy a high-end PC. So that's in comparison to anybody walking in. If anybody walks in and buys something, the probability is just 16%. But if they have bought an expensive TV before, that probability goes up by 3.84 times. So it's pretty good, impressive result. Likewise, we can calculate for the second one. We know that music system is bought by 2,000 people out of 5,000, which means you have a benchmark confidence of 0.4. So what happens to the likelihood of buying music if they have bought expensive TV? So we know this is probability of C given A divided by probability of C. So which means for confidence level of B, it is 0.6923 divided by 0.4, which is equal to 1.73. So rule B is also useful because it explains much more because the lift ratio is greater than 1. If somebody buys a high-end or expensive TV, they are likely to buy a music, and that probability goes up by 1.73 times. But if you have to pick only one rule, obviously rule A says that, hey, if somebody has bought a expensive TV, they're very likely to buy high-end PC because the number of times it goes up by 3.84. But in this example, both have useful information. So if you give any example like this, you can still work by hand on the rules, the confidence ratio, and the relevance of it through lift ratio.